In this video, I'm planning to explain infinity minus infinity and infinity over 1 to the power of infinity cases. I'm going to start with this type of questions. For this type of questions, we have to make the denominators same. Here, infinity, this result is going to be infinity because this is infinity squared down infinity it's going to be. Numerator's power is greater than denominator's power. That's why this expression tends to infinity. Infinity over 3, it's also infinity. So infinity minus infinity case this is. We are going to do some basic operations here to make the denominator same, and we are going to solve with respect to that one. Now we are solving the first question from this exercise. I'm planning to solve the first one only. Limit x tends to infinity, x squared 3x plus 4 minus x over 3 it's going to be, and we are going to make the denominator same. So I'm going to write here 3 and to this denominator 3x plus 4. Then this is going to be equal to limit x tends to infinity. X tends to infinity, 3x squared it's going to be, and here when you multiply cross the denominators, they are going to be equal. That's why directly I'm writing now x times 3x plus 4, the same denominators, 3 times 3x plus 4, it's going to be 3 times 3x plus 4 is the common denominator, it is going to be for us. Okay, then this is equal to limit x tends to infinity, 3x squared minus 3x squared minus 4x it must be, and the down what is written here, 3 times 3x is equal to 9x plus 12 it's going to be. 12 is going to be. Okay, when you simplify 3x squared and 3x squared, then the result is going to be equal to limit x tends to infinity minus 4x over 9x plus 12 it's going to be. And this is infinity over infinity case normally. This is infinity over infinity case. Infinity over infinity. And here also in this case n is equal to m. When the n is equal to m, the limit result it's going to be equal to a over b. If you remember, the coefficient of the numerator over coefficient of denominator it's going to be. Here the greatest powered coefficient is equal to minus 4, sorry. So the answer is going to be equal to, this is going to be equal to 4 over minus 4 over 9 is the answer of the limit. It's going to be minus 4 over 9. Okay, here infinity minus infinity case again, and we are going to solve, planning to solve the last one in this question because they are similar questions. And here if you remember, we were using this method for that one. Here if it is equal to square root of limit of the expression ax squared plus bx plus c, square root of ax squared plus bx plus c, then it's equal to limit x tends to infinity plus or minus with respect to sign, root of a, absolute value of x plus b over 2a. So here in this question I can change this form into this one, and here in the third one, let's see, a is equal to 1 and b is equal to 2. C value is not used in the formula, so it's not important for me. Okay, then this is equal to limit x tends to infinity, square root of x squared plus 2x plus 2 minus x plus 1 is going to be equal to limit x tends to infinity, square root of a, the a value is equal to 1 times absolute value of x plus 2 over 2 times the a value here again 1 it's going to be, this is the b value, and minus x plus 1 is going to be, then it's equal to limit x tends to infinity, 1 times absolute value of x plus 1, it's going to be minus x plus 1, and here the absolute value can be taken out as a positive, because when it tends to plus infinity, this expression is going to be plus. That's why when the expression is positive, you should take directly, I mean the positive form of it, x plus 1 minus x plus 1. This 2, when you simplify, the answer is going to be equal to limit x tends to infinity, x tends to infinity 2, and this is constant, so the answer of the constant of the limit is going to be constant again, which is equal to 2. Okay, the third exercise is 1 to the power of infinity. Here I'm planning to solve 2 of them. I'm going to choose the third one and the C1 and the fifth one, E1. And I want you to remind about the formulas here. There were 3 conditions for each question. Fx limit x tends to x0, which is this expression is going to be fx, and fx is equal to 0 it should be, and gx it should be infinity, fx times gx, limit of this expression, it should be equal to k. Then the limit of this expression is going to be e to the power of k, 1 to the power of infinity normally it is. And the third one, if I start with third one, first I need to change the form into 1 plus fx form, because it says that limit x tends to x plus 3 over x, it should be to the power of x at the same time, it should be equal to limit x tends to infinity x over x plus 3 over x. If you remember, we have solved this question in our lesson also before. That's why the expression can be separated like this by using the rational addition and subtraction rule. Okay, then limit x tends to infinity. X over x is going to be equal to 1 plus 3 over x to the power of x. Now I brought into this form and 1 plus fx to the power of gx. So fx is equal to, in this question, fx is equal to 3 over x it's going to be, and gx is going to be equal to x. The first question, limit x tends to fx, is it equal to 3 over x, is it equal to 0? X tends to infinity, 3 over infinity is equal to, it's equal to 0, so the first condition is satisfied. The second condition, limit x tends to, the second one, limit x tends to infinity gx, it must be equal to infinity. X tends to infinity gx. What is gx? It's equal to x. Is it equal to infinity? Yes, when you replace it's going to be equal to infinity. Second condition is satisfied. And the third one is limit x tends to infinity fx times gx. Fx times gx, limit x tends to infinity fx times gx is going to be equal to k value. And when you simplify, this is going to be equal to 3. So after all these expressions, we can say like this: limit x tends to, sorry, I'm going to write here, this is going to be equal to e to the power of 3, and this is the answer of the question. This is going to be okay. Let me remind you about this one, the E1 I said I'm going to solve. Here about this one I need to remind you about this sign, because the formula it is for 1 plus fx. So what we are going to do here, first I'm going to do this operation here for the E1. I'm going to change the color not to make mistake later. Limit x tends to infinity 1 minus fx, instead of that one, 1 plus minus 2 over 3x plus 1 I'm going to write, and fx becomes, this is going to be fx, and this is going to be 2x plus 1 is going to be equal to gx also. Okay, we are looking for this expression, and this is equal to e to the power of k. You know what is the k value, and I'm going to look for the k value now. Firstly, I have to find, I have to satisfy the conditions. The first condition, limit x tends to x0, which is infinity for the question, infinity minus 2 over 3x plus 1, it should tend to 0. When you put here infinity minus 2 over 3x plus 1, it's going to be equal to minus 2 over infinity, that's equal to 0. Positiveness and negativeness we don't have for 0. Then the second one, this was the first condition. The second condition, limit x tends to infinity, 2x plus 1, that's going to be equal to infinity. Yes, equals 2 times infinity plus 1, again infinity it's going to be. So the second condition satisfied, and by using first condition and second condition, I'm going to find the k value now here. Limit x tends to infinity, minus 2 over 3x plus 1 times fx times gx, 2x plus 1. When you multiply this two expression, you can multiply only by numerator. That's why this is going to be equal to limit x tends to infinity, minus 2 times 2x is equal to minus 4x, minus 2 times plus 1, it's going to be equal to minus 2 over 3x plus 1. And this is infinity over infinity case. This is equal to infinity over infinity case, and n is equal to m case at the same time because the powers are same. So the answer of this question, it's going to be equal to here I'm writing minus 4 over 3, which are the coefficients. So the answer of the question, is going to be equal to e to the power of minus 4 over 3, which is the answer of fx times gx.